What is the molar mass of this compound right here? 124 AMU, 124 grams, 142 AMU, or 142 grams? Now this is a complex question, and to ensure you understand the solution and gain an arsenal of problem-solving tools, let's break this down into simpler problems first. How many carbons does this molecule have? Well, recognizing that carbons are simply all the ends and bends, we count them up for our molecule and we get that there are a total of 10 carbons. Likewise, what about the number of hydrogens? The key to finding the number of hydrogens is looking at carbon, and the rules of bonding tell us that carbon must have 4 total bonds, 4 sticks. However, it's clear that when we represent molecules in bond line form, it limits the bonds we explicitly see. For instance, we see one of this carbon's sticks, but it has 4 total. So to figure out how many hydrogens belong to each carbon, we need to count how many of these 4 bonds are already accounted for with the carbon-carbon bonds we see, and then subtract from 4. For example, this carbon has 4 bonds like all the others, but because we only see 1, it must have 3 hydrogens bonded to it. And when we apply this equation for all of the carbons, we have 22 hydrogens total. With that, what's the molecular formula of this compound? C10H22, C11H22, C11H24. Well, we've already done the work in finding the number of carbons and the number of hydrogens, so we just simply put those things together to get the molecular formula, C10H22. So now we're back to our question of interest. What is the molar mass of this compound? Firstly, acknowledging everything that we know so far about this compound, it turns out that molecular formula will get us to the correct answer. And since carbon and hydrogen both have their own masses as shown in the periodic table, 12.01 and 1.008 respectively, we need to take into account the relative abundance of each for the molecule. 10 for carbon, 22 for hydrogen. So that means that carbon contributes 10 times 12.01, so 120.1, and then you use the same thing but for hydrogen, you get 22.18. And that together gives us 142.3. So it's clearly not A or B, but how do we know if it's AMU or grams? The key to our answer is recognizing that it wants the molar mass. We need to figure out the mass of 1 mole of our compound of interest. That means that we're going to use the molar masses of each element, so it's going to be in units of grams per mole, so that carbon is going to contribute 120.1 grams and hydrogen 22.18 grams. Therefore, the correct answer is 142 grams per mole of this compound. Now, if we had to find the mass of a single molecule rather than a mole, then C would be the answer, because we would use the atomic masses of C and H respectively. Make sure you check out the video on your screen to understand the intricacies and implications of this number at the bottom of the element box.